Hello everybody, welcome into another lesson. So today we are going to talk about the isosceles triangle theorems. And here is the first isosceles triangle theorem. It states that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So, make sure my volume's on. Okay, good. So here we have triangle ABC. It tells us that side AB is congruent to side AC. By the isosceles triangle theorem, then, the angles opposite those sides, so the angle opposite side AC is angle B, the angle opposite side AB is angle C. So by the isosceles triangle theorem, we can then deduce that angle B is congruent to angle C. So that's actually pretty easy. Let me get an eraser, that would help. Alright, now I'm going to change this up a little bit here. This is still going to be the isosceles triangle theorem, but it's going to be part 2. This will be the isosceles triangle theorem part 2. That's what we're going to have here. Alright, let's just reconnect this a wee bit here. Alright, so the second isosceles triangle theorem states that if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So first, what we had was if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Now we have if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So here we see angle B is congruent to angle C. Well, the side opposite angle B, that's side AC. The side opposite angle C is side AB. So by the isosceles triangle theorem, we can then deduce that AC is congruent to AB. So I'll put the congruency markers back now on this, and we have our isosceles triangle. So really not terrible. These really aren't that terrible to deal with. And actually, this will kind of help you when it comes to solving triangles in the future lessons. This will really help you. Then I do have a few corollaries. I do have a few of those, so let's get to them. Here's a corollary. And equilateral triangle is also equiangular. Not equinangular. What the heck is equine? It's not a horse. Okay. So if an equilateral triangle is also equiangular. So let's illustrate that here. We have A, B, C. So we have triangle ABC. We're going to mark sides AB, BC, and AC all congruent to each other. So in this case, this triangle is definitely equilateral. That means that side AB is congruent to side BC, which is also congruent to side AC. They're all three congruent to each other. If it's equilateral, that also means then it's equiangular. So that means all three of these angles, angle B, angle A, and angle C, are also congruent to each other. So then we could say angle A is congruent to angle B, which is congruent to angle C. And then there's another corollary that kind of switches the words. You probably already know what it is. This one states that an equiangular triangle is also equilateral. So first we had that an equilateral triangle is also equiangular. Now we have an equiangular triangle is also equilateral. So the same things here. If angles A, B, and C are congruent to each other, then that means sides AB, BC, and AC are all congruent to each other. So those are some pretty simple corollaries. Then I have two more. I got two more corollaries. An equilateral triangle has three 60-degree angles. So in a few lessons back, we talked about how an equiangular triangle has three 60-degree angles. Well, if an equilateral triangle is an equiangular triangle, that means it also has three 60-degree angles. And you think about it, equiangular, right? A triangle has how many, what's the sum of the internal angle measurements of a triangle? It's 180. So if they're equiangular, you're splitting that three ways. That means each angle has to be 60 degrees if they're equiangular. That kind of makes sense. So if you add these three 60s together, you'll get 180. They're equiangular. All right. One more corollary. This is a little bit bigger. This one's going to be a little bit bigger. Then we'll move on to some exercises. Now this corollary states the bisector of the vertex angle of a triangle, I should say of an isosceles triangle, not just a triangle in general, of an isosceles triangle is perpendicular to the base at its midpoint. Okay, so let me illustrate what that's looking like here. So, oh, what do you know? We'll do triangle ABC again. This time we have an angle bisector of angle A. That's the vertex angle. We can establish that this is an isosceles triangle with AB congruent to AC. Well, since this is an isosceles triangle, and this only works in isosceles triangles, that angle bisector of angle A coming all the way down to BC, the base, it's perpendicular to BC at its midpoint. We'll call this midpoint D. So what you can deduce from that then is that BD would be congruent to CD. And that AD is perpendicular to BC. That's what this would mean. So the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. Now let's say we decided to draw this triangle. Any of these angles could be the vertex angle, right? Well, if I drew it from angle B, it should still be perpendicular to AC at its midpoint. And from angle C, it should be perpendicular to AB at its midpoint. So keep those in mind. Alright, so now we're going to do some exercises here to put what we've learned today into practice. And these ones, it's a classic find the value of x. So it's another one of those, we're going to find the value of x. Let's see, so this triangle here, what do they give us? $50 degrees. This is x. This side's congruent to this side. Okay? So we have an isosceles triangle here. Well, we need to solve for x, but in an isosceles triangle, we have these two sides congruent, so wouldn't the angles opposite these sides be congruent? If this side's 50 degrees for that angle, that means this side also has to be 50 degrees. Right? Well, 50 plus 50 is 100. All that's left then, because you can only go up to 180 in a triangle, all that would have to mean then is that x is equal to 80 degrees. That would be the missing angle measurement. So x therefore is equal to 80. So that one wasn't too terrible. Alright, what about the next one? Great, we have a right triangle. Alright, so we got a right triangle here. They tell us these two sides are congruent. This angle's x. They don't tell us what the other angle is, but let's remember something here from a previous lesson that we've learned. We have learned that the acute angles of a right triangle are complementary, right? And if these two sides are congruent, then the angles opposite those sides are congruent. So the angle here is opposite this side, it's x, so that means the angle here also has to be x. And now the acute angles of a right triangle are complementary, so what does that mean? That means you're going to take that x plus x, set that equal to 90, which then means you'll get 2x is equal to 90, which could only mean then that x equals 45 degrees. So the angle measurement for x, it would give you an angle measurement of 45 degrees. So our past theorems and postulates and definitions still come into play here. What's the next one? Draw another triangle. This one's going to be a little bit different. Ten, 10. This is 12. 74 and x. Okay. So this time they're giving us the lengths of sides. Well, if we see that two of these sides are 10, that means they're both congruent to each other. So both 10 sides are going to be congruent to each other. So let's go ahead and mark that, okay? That means then that the angles opposite these two 10 sides are congruent. So that means the angle over here would also be equal to x. Well, now all that's left to do is some simple math. We're just going to take x plus 74 and set that equal to 180, right? Which then means we'll get 2x is equal to 106, which then means that x equals 53 degrees. So the measurement of x would end up being that x equals 53 degrees. Find the next one here. Another triangle. This time it's not so obvious. Alright, so this is 54 degrees. This is 63 degrees. The side length is x. We don't know that side length. This is 10. This is 11. So this time we need to find a side length. Well, we don't know the measurement of this angle or the measurement of this side. But we can find this missing angle if we just take 180 degrees minus 54 degrees minus 63 degrees. That's just going to give us, let's see, 180 minus 54, that's 130, 126 minus 63, which would be 63 degrees. So this missing angle right here is also 63 degrees. So this time we have two congruent angles to work with. Well, the side opposite 54 is 10. This side opposite the 63 is 11. Well, last time I checked, 63 degrees and 63 degrees are congruent. So that means the sides opposite both of those 63 degree angles would be congruent. So if this 63 is 11, that means the side opposite this 63 would also be 11. So the answer is x would end up equaling 11. That's what you'd end up getting. And all these are by the Isosceles triangle theorem. Or theorems, I should say. Got 4 more mathematical exercises, then I have 4 proofs to do today. Alright, let's do this here. They're turning our whole world upside down this time. So we have an upside down triangle. This angle here is 40 degrees. This angle here is also 40 degrees. This side is equal to 5x minus 8. This side is equal to 2x plus 7. Okay. So we know 2 of the angles, we know 2 of the sides. Ultimately, we want to solve for x. Well, you have 2 congruent angles here, making this an isosceles triangle. That means the sides opposite those angles are congruent. So this side's congruent to that side. If they're congruent, well, that means they're equal. So all you would have to do now is take that 5x minus 8, set it equal to 2x plus 7, which would turn into 3x equals 15, which could only mean that x equals 5. So the answer for this one is that x equals 5. I love these exercises where algebra and geometry mix. To me, they're a lot of fun. Okay, a little bit different here. Probably not the best triangle, but it'll suffice. Let's see, this angle and this angle are congruent. 16, 18, 4x minus 6. So we don't even know the angle measurements, but that's okay. Because we do know that we have two congruent angles of this triangle, which means the sides opposite those angles are congruent. This side here is 18, which would be congruent to this side here with the congruent opposite the congruent angle, which would be 4x minus 6. So all we're going to have to do now is take that 4x minus 6, set it equal to 18, which then means 4x equals 24, which then means that x equals 6. So you end up getting that x equals 6. All right. There we go. We're going to have two triangles in this case. This is 98 degrees. This is x, and these four sides are congruent to each other. So we're going to have a bit of fun. We're definitely going to have a bit of fun here. Well, since we have two triangles, I think it's clear to see that these two triangles are going to be congruent by side, side, side postulate, right? Okay then. If these two triangles are congruent, that means this is a corresponding angle to that one, so this angle down here would also be 98 degrees. And then opposite this side is x, opposite this side would also be x since you have two congruent sides. So now to solve for x, all you need to do is take x plus 98, set it equal to 180, which would then give you that 2x would equal 82, which could only then mean that x is equal to 41 degrees. So therefore the measurement of angle x is equal to 41 degrees. So yes, even knowing how to prove triangles congruent can help you with these. We've just added more tools to your arsenal today with the isosceles triangle business. Okay. Here's a fun one. This is going to be a fun one. We got two parallel lines here. This side is congruent to this side. This angle down here equals 2x. This angle right here is equal to 90 minus x. What do we do? Alright, so what are we going to do here? Well, I think it's safe to say now that we know about triangles, we also know about parallel lines. Keep in mind here that these two lines are parallel. This side of the triangle, the top part, acts like a transversal, does it not? if two lines are parallel cut by a transversal, that means that alternate interior angles are congruent. So you'd have 90 minus x for that angle, which here, now you have two lines, again, cut by a transversal. This angle right here is 2x. Well, you would have to have this angle be congruent to this one by alternate interior angles. So this angle here would be 2x, and if these two sides are congruent, that means these two angles are congruent. So now, all you have to do is take 90, actually let's take 2x equal to 90 minus x. Since they're equal, you set them equal to each other, which would give you 3x equals 90, which could only mean that x is equal to 30 degrees. So you end up getting that x is equal to 30 degrees based on that problem here. So that's why even remembering your parallel line stuff's going to help you. Alright, now I have 4 proofs, which really shouldn't be that bad, to be honest. They won't be all that bad. So let's start with our first one here. There we go. This is angle R, let's see, these are RST for the triangle. Angle 1, angle 3, angle 2, angle 4. Alright, so we got our triangles here. What are we given? So in this particular proof, we're given that RS is congruent to RT. We're being asked to prove that angle 3 is congruent to angle 4. So we're given that side RS is congruent to side RT. We need to prove that angle 3 is congruent to angle 4. So let's go ahead and set up our columns again here. Alright, so we have our statements and reasons. So let's start with the given information. We'll start with the fact that RS is congruent to side RT. The reason for that, of course, it was given. And if it helps you, you can mark up this diagram. If we've established that two sides are congruent, feel free to mark them congruent, which I'm going to do now. That tends to help me. Where can we go from here? Well, if RS is congruent to RT, that means the angles opposite those sides would have to be congruent. So next we can actually say that angle 1 is congruent to angle 2 by the Isosceles triangle theorem. So the reason for angle 1 being congruent to angle 2 is the Isosceles triangle theorem. And you could just abbreviate it how I had it here. Alright. Now where do we go? Well, we look at angle 3 and angle 1. Those are vertical angles, right? Angles 2 and angle 4 are vertical angles, are they not? So for statement 3, we can say that angle 1 is congruent to angle 3 as well as the fact that angle 2 is congruent to angle 4 by the fact that vertical angles are congruent. So we're almost there. Okay, so we've just established 1 and 3 are congruent and 2 and 4 are congruent due to the fact that we have vertical angles are congruent. Okay, so what we can do now, in each of these, we can say here, if angle 1's congruent to angle 3, we can put angle 3 in for angle 1, right? And then if angle 2 is congruent to angle 4, we could put angle 4 in for angle 2. So right away, we can say that angle 3 is actually congruent to angle 4 by the substitution property used twice. So this will be by the substitution property used twice. Okay, so let's go through this proof real quick. We were given a triangle here with some extended sides that created some angles. They gave us that RS is congruent to RT. That was our given statement. That was the reason for that. From there, we could conclude that angle 1 is congruent to angle 2 by the Isosceles triangle theorem. And then we can conclude that angles 1 and 3 are congruent, and then angles 2 and 4 are congruent by the fact of vertical angles are congruent. And then by using the substitution property twice, we can conclude that angle 3 is congruent to angle 4. So that was actually pretty much a piece of cake. That was a pretty simple proof. I got 3 more proofs, then we're done with the lesson. Alright, what's next? What do they throw at us next? Oh, that's an interesting triangle. It's split into 2 triangles. What do they give us here? This is, well, actually I like to write those in black. I like to write the vertices in black. This is A, this is point B, that's point D. CE. C and E. Okay. There we go. Labeled the vertices of these 2 triangles into one. It's 2 triangles in one, really. We have angle 5 up here, angle 6 down here. Let's see what they give us this time. They give us, so we've been given that side BD is parallel to side CE. So BD is parallel to CE. And then they also give us that angle 5 is congruent to angle 6. What do we have to prove? So what are we proving out of this? That AC is congruent to AE. All right. So AC is congruent to AE is what we're trying to prove. So let's go ahead and set up our columns again here. Okay. Now, let's start with one piece of given information at a time. We're just going to start with the fact that BD is parallel to CE, right? You wouldn't want to use all your given information at once. In this particular one, at least. BD is parallel to CE. In fact, I'll go ahead and mark that here on the diagram so we have it. So BD is parallel to CE. Okay. And of course, that was given to us. Alright, so next, if BD is parallel to CE, we have two parallel lines, right? Don't each of these, doesn't BC and DE, don't those act like transversals to these two lines? They certainly do. What does that mean then? That's going to mean that angle 5 is congruent to angle C, and then that angle 6 is congruent to angle E by the fact that corresponding angles are congruent. So those are corresponding angles. So by the fact that corresponding angles are congruent, we can conclude that angle 5 is congruent to angle C and angle 6 is congruent to angle E. Now this would be the time to bring in the fact that angle 5 is congruent to angle 6. Of course, that was given to you. That's a given piece of information. From here, if angle 5 is congruent to angle 6, we could then toss in that by one substitution, if angle 5 is congruent to angle C, then that means that we could put angle C in here for, so 5 is congruent to 6, 6 is congruent to E, so you could say angle C and angle C are congruent by the transitive property. So angle C is congruent to angle E by the transitive property. So angle 5 is congruent to angle 6. Well, angle 6 is congruent to angle E. So 5 is congruent to E, and then you have 5 is congruent to C. So yeah, by the transitive property used twice, you can conclude that angle C is congruent to angle E. Now, if we look at this, if angle C is congruent to angle E, aren't those angles of the master triangle of triangle AEC? So by the Isosceles triangle theorem, we can now say that AC is congruent to side AE. This will, of course, be by the Isosceles triangle theorem. So let's go through this proof again here. We start with the fact that side BD is parallel to side CE. That was given to us. Well, then if those two sides are parallel, that would mean angle 5 is congruent to angle C and angle 6 is congruent to angle E by corresponding angles are congruent. And then we can use the fact that angle 5 is congruent to angle 6 because that was also given to us. And then by the transitive property used twice, we can conclude that angle C is congruent to angle E. And then finally, by the isosceles triangle theorem, we can conclude that AC is congruent to AE. So that's how we got from here to here. I got two more proofs. All right, so what do we got next? See what else we got here. Then we have angles 1 and 2. All right. So there's our pretty little diagram. Let's see what they give us. Given, what are we given? M is the midpoint of JK. We're also given that angle 1 is congruent to angle 2. What we have to prove is that JG is congruent to MK. Alright, so we're given that M is the midpoint of JK. We're also given that angle 1 is congruent to angle 2. Now we have to prove that JG is congruent to MK. So let's go ahead and set up our columns again here. Okay, we'll put the reasons here. I'll put the statements on the left. So let's go ahead here with our very first statement. I would just use the first piece of the information that M is the midpoint of JK. M is the midpoint of JK. Well, that's been given to us, so there's a reason. Now, let's expand upon that. If M is the midpoint of JK, then by the definition of midpoint, that means that JM is congruent to MK. That's going to be by the definition of midpoint. And now what I'm going to do to aid us on the diagram, since we've determined by definition of midpoint that JM is congruent to MK, I'm going to reflect that with congruency markers. There we go. So that just helped us out. Now from here, let's add in the fact that they gave us angle 1's congruent to angle 2. So angle 1 is congruent to angle 2. That's going to be also given. Since we have two angles of the triangle congruent, that makes this an isosceles triangle. Well, by the isosceles triangle theorem, that means that the angles opposite the sides opposite the two congruent angles are congruent. So opposite side 1 you have JM, and if angle 1 and angle 2 are congruent, that means that JG is going to have to be congruent to JM. So we can now say that JG is congruent to JM by the isosceles triangle theorem. Well, this is good. If JG is congruent to JM, that means all we have to do then is substitute JG in here in step 2. By substitution, you get that JG is congruent to MK. So, by the substitution property, we were able to prove that JG is congruent to MK. So let's go through this proof again real quick. So, first step, start out with the given information that M is the midpoint of JK. So that was given. Expanding upon that further, if M's the midpoint, that means that JM is congruent to MK by the definition of midpoint. And then we use the fact that angles 1 and 2 are congruent, that they were given to us, which would mean that JG is congruent to JM by the isosceles triangle theorem. And then by simple substitution, we can conclude that JG is congruent to MK. So, also not that bad of a proof. I got one more proof and then we're done with the lesson. Alright, what do we have for the last one? Good one. There we go. X, Y, Z. So this is triangle X, Y, Z. Okay. We have here angles 3, 4, and then 5. So we have triangle XYZ with these extended lines on this side with angles 3, 4, and 5. What do they give us? So we are given that XY, so side XY, is congruent to side XZ. We have to prove that angle 3 is congruent to angle 5. This one's going to be a piece of cake. This will be a piece of cake. We'll be done with this in no time. So let's set up our two columns. So we got our statements and our reasons. All right, so let's do that. Statement 1, start with your given information that side XY is congruent to side XZ. That's going to be given information. And now that we have established two congruent sides, why don't we mark that in our diagram to make our life easier? So I'll mark these two sides as congruent to make it more visible to us where we're going next. Which means now triangle XYZ is an isosceles triangle, so we can apply the isosceles triangle theorem. Next would end up being then by the isosceles triangle theorem that angle 3 is congruent to angle 4. That, of course, as I just said, is the isosceles triangle theorem. Okay, now from here, angles 4 and 5 are vertical angles, right? We can actually say then that angle 4 is congruent to angle 5 by the fact that vertical angles are congruent. And then by a simple transitive property, we can say that angle 3 is congruent to angle 5. So angle 3 is congruent to angle 5 by the transitive property. Okay, so let's go through this proof real quick. This one was really a piece of cake. Start out with the given information that xy is congruent to xz. That's given. Then that means by the isosceles triangle theorem that angle 3 is congruent to angle 4. And then we could say angle 4 is congruent to angle 5 by vertical angles are congruent. And then finally, by the transitive property, we can say angle 3 is congruent to angle 5. So there wasn't really much to that one. It was a simple 4-step proof. So that's it for this lesson. Next lesson, we are going to talk about some other methods of proving triangles congruent. We'll get one more theorem for triangles in general, and then we'll get some for right triangles that are specifically for right triangles. So I hope everyone has a good night. Take care.